Hi students, this is Miss Oberly with lesson 1-3, day 2. Today we are focusing on the midpoint formula. We'll be talking about some applications of this formula, so like where can you use this in the real world in class? Start thinking about that. When might this come up in your life? Today, by the end of this lesson, you will be able to find the midpoint of any 2 points. So let's just start with what that means. Midpoint is the middle of the 2 points, so just like the center. If line AB has endpoints x1 and x2, I suppose I should pull up my highlighter, on the number line, then the midpoint M, so that's the midpoint of AB, has the coordinates x1 plus x2 divided by 2. So you just add up the endpoints and you divide by 2. So find the coordinates of M, the midpoint of ST, when we know that the endpoints are negative 6, 3 and 1, 0. Okay, so the idea here again is just that I first like to label the point as xy, and then your job is just to add up the x's. So for the first part, we're just adding up the x's, and to find the midpoint, we divide by 2. So add them up, divide by 2. To find the y coordinate of my midpoint, I'm just going to add up the y's, so 3 and 0, and divide by 2. So again, you're just adding up your x's, divide by 2, add up your y's, and divide by 2. So I have negative 5 over 2 and 3 divided by 2. And we can of course simplify this. So write these as mixed numbers, and to name the point, we generally call the midpoint point M. So the point M is negative 2.5, 1.5. Let's check this to see if this looks about right. So negative 1, 2, 3, 4, 5, 6, 3. So one of our endpoints, S, is right over here. The other endpoint, 1, 0, T, is over here. So our midpoint should be somewhere in the middle. So let's check. Negative 2.5, 1.5 is right there. And my line isn't very straight, but you can see that that looks like the middle. So we're checking out okay. So a graph is a great way to touch base with yourself, see if your answer is reasonable. So what about if we're asked to find the coordinates of J? So this is one of our endpoints. I'll just type that. If we know the other endpoint is at negative 1, 2, so right here, and the midpoint of JL has the coordinates 3, negative 5, 1, 2, 3, 4, 5. So this is the midpoint. This is one of the endpoints, and we know that the other endpoint is going to be probably somewhere down here. Actually, I'm glad I just realized this right now. Let me read this again. So find the coordinates of J if K is the midpoint. So actually, they're saying that this K value is our midpoint. So that's the center. So if that's the center, can you picture where our other endpoint is probably going to be? So this is one endpoint, this is the center. The other endpoint is probably going to be up here somewhere. So if we end up in quadrant 2, we know we did something right. All right, so this time we know the midpoint and we know one endpoint. We're trying to find the other endpoint. So we have to think about how this midpoint formula works. Let's start with just the x's. So if our midpoint is negative 2 or negative 1, 2, we know that when we add up the x's of our endpoint, one x we don't know, the other x we know is 3, and we divide by 2, we will get negative 1 out, because that's what our midpoint is. Do we know how to solve equations with just one unknown? You bet. You're pros at that now. So we can multiply both sides by 2. We're left with negative 2 equals x plus 3. And then we can subtract 3 from both sides, and we're left with x equals -5. Does -5 seem reasonable for our x value? It does to me. Now we need to find our y value. So I'm just going to draw a squiggly line for finding our y. Same process. We know that the y of our midpoint is 2. So we know that all of this setup is going to equal 2. And we don't know one of the y values, but the other y value is -5. So if we add up an unknown plus -5 and divide it by 2, we get out 2. So let's solve for y. Multiply both sides by 2. We're left with 4 equals y plus -5, or y minus 5. We add 5 to both sides, so y equals 9. And if we're at -5, 9, I would say that absolutely looks like we're right on track. So check for reasonableness definitely works. So our other endpoint is -5.